circadian rhythms underpin almost every aspect of our health and well-being. And that was the bit I wanted to get across within Lifetime, and that we, in a sense, avoid these rhythms at our peril. For biology to function, it requires the right materials in the right concentration, delivered to the right tissues and organs at the right time of day. And it's the circadian system that delivers this extraordinary temporal structure. What are the consequences of ignoring this biology, as we do for night shift work, 24/7 society? And it's not all doom and gloom. By understanding this biology, we can very much enhance our health and our well-being.
Hey friends, and welcome back to Deep Dive, the weekly podcast where every week I have the immense privilege of sitting down with academics and entrepreneurs and authors and creators and other inspiring people, and we find out how they got to where they are and the strategies and tools we can learn from them to help us live our best lives. Now, this episode is very exciting. It is an interview with Professor Russell Foster, who is the Professor of Circadian Neuroscience and Head of the Department of Ophthalmology at the University of Oxford. He has recently published this new book, Lifetime, The New Science of the Body Clock and How It Can Revolutionize Your Sleep and Health. And so in this episode, I asked Professor Foster all about the circadian rhythm, the body clock, and all of the different practical, actionable strategies that we can use that take advantage of our circadian rhythms and our body clock to help level up our health in terms of our eating and our exercise and our nutrition and our sleep, crucially. So I hope you enjoy this conversation.
What is the difference between your book, Lifetime, and Why We Sleep?
Fundamentally, I approach the project really from a circadian basis. So a 24-hour biology. So essentially everything is being adjusted to a lesser or greater extent by this internal body clock, our circadian rhythms. Sleep is part of it. And so I've taken a much more sort of global look at our 24-hour biology and made sleep part of that, but not the main focus.
Okay. Yeah, because the subtitle, the new Science of the Body Clock and How It Can Revolutionize Your Sleep and Health.
Yes.
I guess, so it's kind of weird. So like, I mean, I went through 6 years of medical school, 2 years working as a doctor. We did so little on circadian rhythms beyond like a second year neuro lecture on the eyes, where eyes are so complicated anyway. It's just like, oh my God, photoreceptors and this and all of the things. That circadian rhythm was very much an afterthought. Sleep was very much an afterthought. Nutrition was very much an afterthought. Yep. And it was only really when I read Why We Sleep that I started to be like, oh, the circadian rhythms are in fact a thing. And then listening to a few Human Lab episodes about it, around kind of getting light in the morning versus not in the evening. It's like, oh, wait a minute, caffeine, adenosine, and all these things, which kind of words that I picked up from medical school, but didn't quite apply to the context of how we can actually improve our lives. So I guess like what's going on with the body clock broadly? Where do we start the discussion?
Well, I think the remarkable thing for me is that we've spent 20, 25, 30 years trying to understand how these endogenous 24-hour oscillations are generated. When I started, and I moved from the UK to the States, this was the focus. How does the clock tick? And some of the great people, the Nobel Prize in 2017, Rosbach, Hall, and Young, we would come to University of Virginia because we were all part of the same National Science Foundation Center for Biological Timing, give talks, and they used to get it wrong a lot. But as the data accumulated and the facts changed, they corrected the story. And so what we had by the Nobel Prize was a pretty complete understanding how you can generate a biological clock, which is completely awesome. Essentially you've got a bunch of clock genes which are turned on, they produce a bunch of proteins, they form a complex, they go into the nucleus, they turn those genes off, the proteins are then broken down, and then they're released from this inhibition and can start producing more proteins again. So you have this 24-hour oscillation in protein production and then degradation, and that's the essence of the clock. And certainly I was involved in early experiments showing that the master clock in the brain is a group of 50,000 cells called the suprachiasmatic nuclei. And we thought that would drive rhythmicity, and it would impose a 24-hour order on the body. We got that wrong. In a sense, every cell in the body has this internal clock. And so what you've got is a master clock in the brain then coordinating the rhythmic activity of billions of individual cellular oscillators throughout the organ systems of the body, fine-tuning our biology to anticipate the varied demands of activity and rest and the day-night cycle. And so with that exquisite mechanistic understanding and the knowledge, for example, that a single amino acid change in one of those clock genes can either make you a morning person or an evening person is so cool. It's the best system that we have of understanding how genes and their protein products interact to generate behavior. I mean, it's still the best example we have. So, but in parallel with that exquisite mechanistic understanding, which is really my background, because I'm interested in how light interacts with the master clock and regulates it, was the appreciation that circadian rhythms underpin almost every aspect of our health and well-being. And that was the bit I wanted to get across within Lifetime, and that we, in a sense, avoid or ignore these rhythms at our peril. Because if you think about it, for biology to function, it requires the right materials in the right concentration delivered to the right tissues and organs at the right time of day. And it's the circadian system that actually delivers this extraordinary temporal structure. And so what are the consequences of ignoring this biology as we do for night shift work, 24/7 society? And you know, that wonderful arrogance of being human. I mean, part of our extraordinary achievement has been that we believe that we're independent of the constraints of the grubby world of biology, and we're not, you know. And it was really, I think it was a bit of a wake-up call to think, hang on, you need to think about this. And it's not all doom and gloom. By understanding this biology, we can very much enhance our health and our well-being.
Love it. So, okay. So I have so many like specific questions, but I wonder if we start more further upstream. So you've got suprachiasmatic nucleus with its 50,000 cells or so that are sort of the master clock of the body. And they're somehow helping regulate the other billions of cells that we have in the body, which also have some level of like circadian rhythmicity to them.
Yes.
Let's say it's nighttime for a cell versus daytime for a cell. In like, I don't know, the finger. Like, what difference does it actually make?
The clocks are sort of made in broadly the same way. We don't think there's any fundamental difference in the master clock compared to a finger clock, for example. But their phasing, the alignment of those clocks can be very different. And it's essentially how they take their reference cue from the master clock that's important. Now, what you've got is a master clock, and it's no use to anticipate these daily changes unless it's set to the real world. And so our interest has been, well, how does the master clock use the dusk-dawn cycle, the light-dark cycle, to regulate internal time? And that's really how I got into this sort of mechanistic side of things. And the appreciation that, in fact, it's not the visual cells, the rods and cones, that are providing this light-dark signal. It's, in fact, a third photoreceptor in the eye. And so the eye, we can think of it, I mean, it's, you know, obviously the eye is so cool in lots of different reasons, but it's both the organ of space through vision, but it's also the organ of time because of its regulation of the internal master clock in the brain. And if you don't have eyes, you are both space blind, but also time blind. And in fact, we're working with Blind Veterans UK, those individuals who have radical eye damage or they've lost their eyes. They're drifting through a world without time. These are extraordinary individuals, very, very keen to be independent. And some of the discussions I've had, you know, one chap was telling me, I feel so angry because I feel my body is trying to trick me all the time, and went on to tell me about a story whereby he knew that Wednesdays is when he cut the grass. And so he woke up, knew it was a Wednesday because that was the next day, went downstairs and had worked out a way to cut the grass, being completely blind. And then his wife came down and said, it's 3 a.m. in the morning and you're going to drive the neighbors crazy. And it was that incredible sense of frustration. It's a bit like unremitting jet lag for the rest of your life. And so the most recent work that we're doing is, you know, we discover these new photoreceptors, and that's so kind of cool. You've got this dual function of the eye, but it's really working out how they interact with the molecular clockwork. And we're now at a stage where we've got drugs which can mimic the effects of light on the clock. And the research I'm doing now is to try and develop those drugs so that we can give them to individuals with radical eye disease, no eyes, and give them back a sense of biological time. It's not just actually the profoundly blind. We've done quite a bit of work in the space of psychiatric illness. So the sleep-wake patterns of individuals with schizophrenia are utterly smashed. I mean, to an extent I would never have believed until we'd done the studies. And so I also see a role for those drugs in correcting, as an acute corrector of the circadian sleep-wake cycle, and then hopefully not to use drugs and then use light, but as an immediate corrector. In the context of Alzheimer's and dementia, the reason my kids will send me off to a nursing home will be because I'll be wandering around in the middle of the night terrifying the grandchildren, if they ever produce any. But seriously, if we could delay the point at which one has to sort of send an aged relative to the nursing home because of their massively disrupted sleep-wake, this would be incredibly beneficial, for the healthcare sector, but also the emotional trauma that families go through when they have to make this very painful decision. So by understanding the nature of biological time, I think there's some really exciting opportunities.
Yeah, that's really cool. So how do the photoreceptor cells respond to dawn and dusk to regulate?
It's such a cool question because they are. I mean, I got into this because I couldn't understand how the visual cells, the rods and cones, which grab light in a fraction of a second, milliseconds, then they forget they've seen that light, and that's how we get an image of the world. And if they took longer, then our visual world would be a blur. As we moved our head, it would be a smear, not a series of sharp images. And I couldn't see how the rods and cones could extract dawn-dusk information over long periods of time. And what we did know before we started is that they're really quite insensitive to light. So you needed a lot of light for a long period of time. And I guess having a background in sensory ecology, whereby sensory cells are fine-tuned to their, the demands, the sensory demand, I couldn't understand how a visual cell could also act as a circadian cell. So we started working with mice with hereditary retinal disorders, whereby their visual cells had largely degenerated. They were visually blind. But what was so extraordinary is that when we looked at their ability to regulate their circadian rhythms to a light-dark cycle, and essentially what you do is you put them in a running wheel, like a hamster running wheel, and look when they run and when they don't run, and you get a beautiful readout of their circadian behavior. They could do it perfectly well. When you covered the eyes, then this ability had gone. So there had to be something else in the eye. Now, when we proposed that, as I talk about in the book, I mean, I remember there was a big meeting in the States where I said, so these data are consistent with the fact that there could well be another receptor system in the eye. This person at the back of the auditorium stood up, and I thought, okay, well, they're going to ask a question, fair enough. And I sort of looked at them, and they looked at me, and they just said bullshit and walked out. and it got really nasty. I mean, grants were hit the deck. One comment from a referee was, is Foster seriously telling us that after 150 years of research on the eye, we'd missed an entire light detecting system? And so, I was a bit younger then, full of I suppose, arrogance, perhaps. Said, yes, these are the data. But it took us a decade to get better and better data. Ultimately engineering a mouse with absolutely no rods and cones. So you couldn't use the argument, it's just a few rods and cones left that are mediating this light response. And what we discovered is this entirely genetically engineered rodless coneless mouse will regulate its responses to light, circadian responses to light perfectly normally. And that led us to find in a mouse a group of ganglion cells that were directly light sensitive. The ganglion cells are the cells that form the optic nerve of the eye. And about 1 out of every 100 of those is directly light sensitive. David Burston found the same thing in the rat, and Dennis Dacey found the same thing in monkeys. So, after we'd slogged away for a decade, then at about the same time, we in the mice, other people in rats, other people in rats showed, there's something else.
Thing, yeah.
And that, I think, has been really incredibly exciting because it's not just called biology. It has direct clinical application. And that's where the last gasp of my scientific career is going, is using that information, hopefully for health and well-being.
Just a quick message from one of our sponsors and we'll get right back to the episode. And this episode is very kindly brought to you by Heights. Heights is a brain care smart supplement. It is 2 capsules that you take every day. I've been taking it for the last 12 months, and it contains over 20 evidence-based micronutrients that you need to keep your brain and body healthy. Like I said, I've been taking Heights every day for the last 12 months, and through that, I've actually become friends with the founder, Dan, who we actually had on season 1 of this podcast. And this season, we also have an interview with neuroscientist and psychiatrist Tara Swart, who is the chief science officer at Heights as well. And one of the things I love about Heights is the fact that every single thing they do is very evidence-based. Over on their blog, on their website, they've got tons of articles along with links to all of the different papers that they've cited that show all the benefits of the various micronutrients that they've got in these 2 little capsules. And the best thing about taking these is that it's just 2 little capsules every morning, so you don't have to deal with green sludge or any other kind of faffery. It's just literally taking 2 pills. It's super easy to sign up. You just go on the website, you put in your address, and they send you either a monthly or a quarterly subscription. I sign up to the quarterly one myself because A, it's cheaper, and B, I'd have to take fewer deliveries. And if you use the coupon code ULI15 at checkout, that will give you 15% off the already discounted price of the quarterly subscription, so you can try out Heights to your heart's content. So thank you so much, Heights, for sponsoring this episode and for helping improve my own brain care. What was that like when you first did that experiment covering up the eyes of the mice and realizing, hang on, they lose their circadian activity? Was that like a, oh my God moment, or was it like a, oh, there must be something else going on here?
No, it was an oh my God moment because it was consistent with the sort of the theories. But when you had unambiguous data, so the other thing is, of course, my background is in comparative biology. My first degree was zoology. And I was aware of weird photoreceptors. So non-mammalian vertebrates have pineal photoreceptors. They even have photoreceptors in the hypothalamus. I mean, I know that sounds crazy, but huge amounts of light actually penetrate the brain.
Like through the skull?
Through the skull.
Oh, wow, okay.
And birds, for example, regulate their seasonal biology. They can detect the increasing and decreasing day lengths with a receptor in the hypothalamus. In fact, I worked on those before I worked on mammals. So the conceptual leap that there could be a weird receptor in the eye wasn't so huge for me because I'd come from a background of weird photoreceptors. And I think that's a really, really interesting perspective because so much of exciting science is at the interface between different disciplines.
Yeah.
Now, the chap that said we've been studying the eye for 150 years was absolutely dead right. But they've been studying vision. They hadn't been looking for another role for the eye. And so you find what you're looking for.
Yeah. And so someone with your background where you've been studying these in an entirely different context, you put sort of 2 and 2 together almost.
Yeah. And it really, my undergraduate project was recording from the sort of the parietal eye electrophysiologically from tadpoles. And it's so cool because, shine a light on this tiny little structure and it changes its electrical activity and it probably regulates swimming behavior. Did that with my 3rd year project supervisor, Alan Roberts, and so it was, I think that breadth of exposure to different areas of science is so important. Yeah. And sadly, because there's so much to learn these days, we don't really have time for the comparative bit.
Yeah, I suppose to get advanced in any one specific field, you have to devote your life to that rather than kind of dabbling with other fields as side hustles almost. Yeah. Okay, so we've got the ganglion cell in the optic nerve, which is responding to light. Is it responding to amount of light or wavelength? Like what is it responding to and what's happening then?
This is what actually the field is struggling with at the moment because, of course, what architects and the lighting industry want is what they call human-centric lighting.
Okay.
And which is basically lighting that optimizes human function, physiology and behavior. Yeah. So what the lighting industry has really focused upon is aesthetics. Does it feel nice? And is it bright enough for color vision, for example? Okay. So that's been largely. Now, of course, what they want to do is enhance the light environment for the regulation of the clock in the industrial setting and also the domestic setting. But the problem is we haven't got all the parameters in humans. Humans are profoundly insensitive to light, and we might want to ask why in a second. I mean, compared to a mouse's circadian system can detect light of 1 lux, which is, little more than moonlight. We get up to 100,000 lux on a bright sunny day. So that's incredibly insensitive. And in fact, it wasn't until 1987 when scientists from Japan showed that, in fact, humans can regulate their circadian system by light. It was always assumed, and when I was doing my PhD, when asked that question, how do we regulate our clocks? It was always, it's when we eat, and it's our social interaction. And the problem is, everybody had been using stimuli that worked brilliantly for mice, but there was just not enough. And what the Honmas did was something like 5,000 lux for, I think it was 6 or 8 hours. Then they got entrainment. And
entrainment meaning
the regulation of the internal clock to the external world. And wavelength, we showed that these new photoreceptors are maximally sensitive in the blue part of the spectrum. To be specific, 480 nanometers, which is the kind of blue you get on a really blue sky on a beautiful sunny day. Why? Well, it could be because at twilight, the dome of the sky is enriched with blue light. Of course, the horizon, you see it as orange, but if you look up, it's that beautiful blue. And it's that wavelength where these receptors are most sensitive. And of course, it's at dawn and dusk when these receptors need to be able to detect the light. And so we think, but it's a Just So story, that they're sort of sensitive in the blue part of the spectrum for maximum sensitivity at that time of day. However, although we showed there's a separate photoreceptor, and we originally conceived it as visual rods and cones, non-visual photosensitive retinal ganglion cells, actually, of course, as you might predict with biology, it's more complicated than that. In fact, we now know that the rods and cones are capable of regulating the photosensitive retinal ganglion cells.
Okay.
So, in fact, the spectral range can be quite large, because the cones go down in humans to, 420 nanometers in the sort of violet area, and they go out to 560, which is sort of green-orange. So, how they communicate with the photosensitive retinal ganglion cells is unclear. Under what circumstances? Whether they add to the sensitivity, and there's some evidence from the monkey literature that they might actually inhibit the photosensitive retinal ganglion cells. So it's a complicated light environment that they're responding to. And in fact, we and others have argued that it might be, color vision might have evolved to add additional information. Because, of course, at twilight, you get a change in the color of the light environment. And if you've got receptors tuned to different colors, they can ratio those changes and then pass that information on. So it might be the photosensitive retinal ganglion cells are just doing brightness, but they're getting additional time information from the visual cells relating to the changes in the color of the environment. Now, we don't know. But there's all those really fascinating issues. The sensitivity issue, I think, is really why are we so insensitive to light? And I'm guessing, but it could well be that humans, of course, have been playing with fire for maybe 1 million years, and of course, firelight is quite bright, and it could give a confusing light-dark signal. There might have been rapid selection against sensitivity so that these receptors weren't
we're not
confused.
overly responding to a bonfire at night.
Exactly, yeah. So it's tuned to the sorts of light you get in the environment at dawn and dusk.
And so what sort of proteins are being up or down regulated once, like with the circadian cycle? So the key targets for light activation are 2 proteins called PER1 and PER2. So what do PER1 and PER2 do?
Well, they're they're really critical in the feedback, but by turning them up, or in fact, you can inhibit them as well, will mean that you'll advance or delay that oscillation. So you can use them in nature to align that clock to the external world. I should have said that, of course, the molecular clockwork isn't exactly 24 hours. So for most of us, the body clock is a little bit, under constant conditions, is a little bit longer than 24 hours. So if you or I went to a deep, dark cave, constant light, constant temperature, and people, of course, have done that, then we would get up a little bit later and later and later each day. And so what happens is that the daily light exposure nudges the clock into alignment by upregulating, particularly per 1 and per 2 in that feedback loop.
And so once, presumably quite a lot downstream of that, you would have, I don't know, in the morning, the body would decide to be more alert, and in the evening, it would decide to be more sleepy. Like, is that ultimately what's going on?
Yeah, I mean, essentially what the clock is doing is providing a temporal reference cue for all downstream physiology and behavior to align itself. So in anticipation of waking up, the blood pressure is rising rapidly, the cortisol levels are rising rapidly, and alertness is being turned on. And of course, at the other end of the day, those physiological and behavioral parameters are sort of declining or going into a different state. I think it's important to say that they're not being turned off. They're just going into a different state, because sleep is not a shutting down of biology, as we've sort of you may well have been taught, even as recently as when you did your medical degree. But in fact, it's going to a different state, which is, in fact, some areas of the brain are more active during sleep than they are during wake. And so what's happening whilst we sleep is that information that we've acquired during the day is then laid to memory. And in that new information is then integrated. And so if you want to come up with novel solutions to complex problems, a night of sleep has been shown to hugely enhance our capability of doing that. So the brain is sort of not only just sort of storing facts, it's actually playing with information and coming up with new ideas, which is why sleep is so important, because it's that incredible capacity that humans have of problem solving. And it's sleep that really helps us to do that. At the same time, the brain is regulating the clearance of a whole range of toxins from the body, and realigning our metabolic pathways so that the stuff that's been burnt up during the day is then rebuilt at night, so we can do it. So it's these wonderful different states of sleep and wake that are being underpinned by the clock, and of course it's immensely complicated. So you have to have that timing, across the day. And in space, so the right organs are doing the right things.
Just a quick message from one of our sponsors, and we'll get right back to the episode. And this episode is very kindly brought to you by Shortform. Shortform is the world's best service that summarizes books. But it's way more than just book summaries. They almost have a whole study guide for every book that they've got on the platform, where they've got a one-page summary, and then they also have chapter-by-chapter breakdowns. And it's not just chapter-by-chapter breakdowns. Also, in between the chapter breakdowns, they have interactive exercises where you can engage more readily with the ideas in the book. Shortform covers non-fiction books from a bunch of different genres that you might be interested in. For example, they've got a load of stuff in the business world. So if, for example, you are an entrepreneur or you want to become an entrepreneur, that'll be great for you. They've got books in motivation, they've got books in education, they've got books in lifestyle and communication. Basically, any genre of like non-fiction, personal development-y, self-helpy stuff that will help you level up your life. It's all there on Shortform. Shortform publishes new book guides and articles every week. And if you're a subscriber, then you get to vote on what book they cover next. And in fact, through that system, I have voted for various books. For example, I've recently revisited the Shortform Guide to Atomic Habits by James Clear. I've read the book once, I think when it first came out, when he was interviewed on Matt D'Avella's podcast, and I thought the book was amazing. But to be honest, like with most nonfiction books, once you've got the key ideas from it, rereading the book, especially sort of like in fairly close proximity to your rereadings, doesn't necessarily help, as much as I love James Clear. But the Shortform Guide to Atomic Habits is great for revisiting the key ideas. Anyway, if any of that sounds up your street and you would like to sign up to the world's best service that summarizes books, then head over to shortform.com/deep dive, and that will give you a completely free 5-day trial, and you can try out the service to your heart's content. That link will also be in the video description and in the show notes, and thank you so much, Shortform, for sponsoring this episode.
So I feel like we've got a good a basic kind of grounding in the importance of the circadian rhythm in regulating important aspects of, I guess, physiology and psychology. Yeah. Can we talk about sleep now?
Yeah.
So, I mean, I read Why We Sleep, and I've listened to a bunch of podcast episodes about this, but I'd just love to get your take on a few of these like frequently asked questions about sleep. So I guess the first one that comes to mind is 6 hours, 7 hours, 8 hours, 9 hours. What's going on there?
I think the key thing for me is that one shoe size doesn't fit all.
Oh, okay. Yeah.
And one of the sort of slight frustrations that's emerged is that an average value is taken as the optimum value for all of us. And of course it isn't. Across adults, for example, healthy sleep can range from 6 hours, maybe slightly less than that, out to 10 or 11 hours. And so, yes, there is an average, but actually there's so much individual variation. It's really, I think, wrong to impose a specific amount for each of us. And the point of the book, to some extent, is to allow people to define what's optimal for them.
How do we do that?
How do you do that? So, so how do you know if you're not getting enough sleep? Well, it's the kind of things our grandparents probably would have told us if asked that question, which is that do you need a partner or an alarm clock to wake you up in the morning? Does it take you a long time to wake up? Do you crave caffeinated and sugar-rich drinks during the day to keep you awake? Have your friends, family, colleagues reported that you're showing a lack of empathy, increased frustration? They may have noticed that you do stupid and unreflective things. And when given the opportunity to sleep, let's say at the weekend, and very notably on holiday, do you find your sleep patterns change? And it's really defining what each of us needs and then trying to adopt behaviors that defend that sleep pattern. And we know, for example, that the duration of sleep varies enormously between individuals. But not only that, their timing, going back to the molecular clock, there are subtle changes which can make you a morning person or an evening person. But also going back to light, that can contribute to what's called your chronotype, your morningness and eveningness. So morning light advances the clock, makes you get up earlier. Evening light delays the clock, makes you get up later and go to bed later.
Evening light as in?
Dusk light. So dusk delays, morning advances the clock. So you're constantly being nudged backwards and forwards.
Yeah.
And of course, one of the problems of our society is that we don't get asymmetrical exposure to light, which can be a problem.
Asymmetrical
as in you're not getting an equal amount of advancing and delaying dawn-dusk exposure. So we looked at a bunch of university students around the world, Australia, New Zealand, Germany, Holland, and in the UK. And we showed that those with the latest chronotype, those that like to get up late and go to bed late, were not getting morning light, which would have advanced the clock, made them get up earlier. They were missing that. They were sleeping through the morning. But they were getting evening light, which would delay the clock.
Which causes them to sleep even later.
Yeah. So our sleep timing is dependent upon our genetics and when we see light. But also, there's another factor, which is how old we are. So from about the age of 10, there's a tendency to want to go to bed later and later and later. Peaks in lateness in males about 21 and a half. In females, about 19. So men tend to be later for longer. And then as we age, we sort of move to a more morning chronotype. The time we're in our late 50s, early 60s, we're getting up and going to bed at about the time we got up and went to bed when we were 10. And that actually change almost perfectly correlates with the changing levels of estrogen and testosterone. So that sharp rise during puberty and then the sort of decline into old age. So the point I'm making is that not only is there lots of differences between individuals in terms of their preference for how long they want to sleep and when they want to sleep, but it changes as we age. Therefore, it's completely daft to try and define the optimum sleep, the optimum sleep duration. You must get 8 hours. And I think it was kicking back against that, which was one of the reasons for writing the book. I mean, people have actually come up to me after a public talk, and this was before lockdown, and one person said to me, I don't get 8 hours of sleep. Am I going to die? And I said, well, I can assure you you're going to die. But it may have nothing to do with your sleep. And so people have become frightened about their sleep. Rather than embracing the sleep that they get, they become anxious about it. There was, and it's reinforced by sleep apps. It's worth bearing in mind that at the moment, no sleep apps are endorsed by any of the sleep federations or FDA approved. And of course, when you look at the validation of many of these apps, you'll go into the paper and you'll see it works perfectly for 8 undergraduates, or in California. And that's about it. But of course, the point I've just made is that sleep changes as we age and between individuals. And so one algorithm is also not appropriate for telling us what good sleep is. People have come to me and said, "Oh, do you believe in slow wave sleep?" And I've sort of said, "Yes, kind of. Why?" And they said, "Well, I don't think I'm getting any because my app is telling me I don't get any slow wave sleep." And of course, these apps are profoundly, they can't detect that. They don't have the sensitivity to do that. And so people can get very badly misled. So there's the sort of the mantras that are a bit frustrating. You must do this, you must do that. But it's reinforced by sleep apps saying, "Oh, you had a good night's sleep or a bad night's sleep." And again, we should be listening to our own biology using very straightforward sort of criteria that we've just touched upon.
Nice. Okay. I have another potential myth that maybe you can debunk, which I've heard a lot, which is that you might think you can get by with 6 hours of sleep, but when you're 65, you're more likely to get dementia and Alzheimer's and stuff. So make sure you get your 8 hours, Sonny, Jim.
It's a good point. I mean, I would not want to marginalize the importance of sleep. Absolutely. But I do think that we need to take responsibility for it. Now, if you are in your middle years and you are, doing crazy sorts of things in terms of business and all the rest of it, and are chronically sleep deprived, then there is evidence that chronic sleep deprivation in the middle years will predispose your risk, increase your risk to Alzheimer's and dementia. So I think that's a serious issue. But again, it's horses for courses. And I think most people know if they're not getting the sleep that they need.
Yeah. How important is it to wake up at the same time every day?
I think it is important because it reinforces all of the sort of signals that regulate the circadian system. So eating at the same time, getting light exposure at the same time, that all acts to stabilize. However, having said that, there's going to be an occasion where you have a party. You're going to get up late, and sleep is very dynamic. I really can't emphasize one size does not fit all.
Yeah.
And because it's such a dynamic and variable behavior, we can, it can be tweaked and it's flexible. The other really interesting myth that so many, again, people sort of perpetuate the myth. It's not only 8 hours, but it's 8 hours of uninterrupted sleep. And of course, what we know from, Roger Eckert's work from his historical studies looking at sleep patterns in the pre-industrial era is that human sleep almost certainly wasn't a single 8-hour block. So you hear in the literature, I had a wonderful first sleep, and I didn't have such a great second sleep. And Roger talks about a wonderful French doctor who says young couples should make love after their first sleep when they are less tired and will be better at it. I mean, so you've got this literature which sits out there, and that then encouraged people like Tom Weir to say, okay, well, let's find out what happens to modern humans if we bring them into the lab, give them 12 hours of light, 12 hours of darkness, and lo and behold, you get what's called biphasic, a couple of episodes of sleep separated by wake, or indeed polyphasic, which is multiple sleeps with interruptions throughout the night. If you look at all mammals, again, that wonderful comparative perspective, all mammals show, they don't show a consolidated bunch of sleep. Yeah. It's polyphasic or biphasic. And indeed, societies today without electric light show multiple wakings and sleepings. So that bit of information is not out there. And so when people wake up in the middle of the night, think, oh my God, that's it. I'm never going to get back to sleep. I might as well start drinking coffee and doing my emails, which is nonsense. If they stay calm, you don't necessarily have to stay in bed. You can keep the lights low, do something relaxing, you will feel tired again and then go back to sleep. I know people who, listen to Radio 4 Extra and, will get through. One person told me just the other day, they found that Melvin Bragg is absolutely spectacular for getting them off to sleep. Now that's, I love In Our Time, but in the middle of the night, that perhaps that voice is what's required to just gently get you back to sleep. And again, it's finding out what works for you, what you find relaxing to get you back off to sleep. But so many people are just terrified of waking in the middle of the night. In fact, there's a condition recognized now called sleep anxiety, where people are getting very anxious about going to sleep because they're frightened of how long it'll take them to get to sleep, but also if they wake up in the middle of the night.
I feel like around the early 2010s, there was a bit of a movement of people trying to figure out polyphasic sleep as a productivity tool.
Oh, God,
What's your take on that?
In fact, I'm part of a National Sleep Foundation, which is based in the States, consensus document on this. And you have these various patterns whereby there's a total of something like 4 or 6 hours of sleep. It maybe 2 hours at night with various fragmented sleep during the day. And all of the data suggests that this is a really bad idea. And it's sort of become very popular in the business sector, where people are sort of saying, "Oh yeah, I've just," and actually, short term you're probably okay. Long term, it's really a bad idea. And going back to the point we were talking about earlier, assessing one's own sleep needs, you've got to be pretty careful about it because you can delude yourself. The problem is that the tired brain can become so tired it can't detect how tired it is. And this has been shown in taxi drivers. Asked, do you okay working through the night shift? They say, yeah, no problem, fine. Yeah. You then look at their cognitive abilities and they're on the floor. So you again need to be genuinely in tune with what your individual sleep needs are and the impact of sleep disruption.
Just a quick note from one of our sponsors, and we'll get right back to the episode. And this episode is very kindly brought to you by Skillshare. If you haven't heard by now, Skillshare is probably the single best place in the world to learn anything online. And the best thing about Skillshare sponsoring this podcast is it's very exciting because I have actually been a teacher on Skillshare since 2019, and I actually have 13 classes on Skillshare. Yes, 13. Most of the online courses I've ever made are on Skillshare, where you can access them completely for free by going to Skillshare.com/deep dive, and you'll get a 1-month free trial. Anyway, on Skillshare, there are thousands of classes on all sorts of topics, from entrepreneurship and business to lifestyle design to interior design to cooking to graphic design to video editing, like loads of stuff. But in particular, you might like to check out my own classes on productivity. I have 3 classes on Skillshare, all about productivity. We have the productivity fundamentals, we have productivity creators, and we have productivity strategies. And so if you want to do more things with your time, if you want to do more of the things that matter to you in a way that's fun and sustainable, you might like to check out those classes, which again, you can check out completely for free by just going to Skillshare.com/deep dive. And then once your trial is over, you can choose to carry on with the subscription. I pay for Skillshare. I think it's great. They've got loads of classes. And so it becomes one of my first places to go to if I want to teach myself anything at all. So check out my classes on Skillshare, and thank you so much, Skillshare, for sponsoring this episode.
One thing that I've had in my mind a little bit is, because I've heard in a bunch of podcasts and things as well that you should try and wake up at the same time every morning, and preferably on weekends as well, because circadian rhythm and stuff. Yeah. But I'll occasionally have a night where I've had friends over until like 1 a.m. Yeah. And then I'm like, okay, so I normally wake up at 7:30. If I sleep at 1:30 and maybe I'll get 6 hours of sleep, is it better for me to just actually wake up at 7:30, or should I just have a bit of a lie and wake up at 9:30?
I think it's fine to have the occasional lie-in. Okay. And I think this is it. It's these regimental sergeant majors of sleep. It's flexible. I mean, I think we can think of, we don't do the same behavior when we're awake. And I think during sleep, it's again a dynamic. It's a dynamic behavior, and there's flexibility. Clearly, there's a baseline, that we need to achieve, but it's a wobbling baseline.
Yeah, because I think like over the last couple of weeks, I have actually been sort of putting in my journal, but I feel particularly tired today. Oh, I only did get like 5.5 hours of sleep last night because regimental sergeant told me I should wake up at 7:30 even if I'm tired.
Yeah. And of course, catch-up sleep can work. You've just got to be very careful about it because it can mean that you don't get that morning light, which is so important to set the clock.
Yeah.
And if you sleep through. So, it will cause a wobble. But if the next day you're getting up at the right time, then it's fine.
Yeah. When you say morning light, are we talking like what sort of time are we talking? What sort of lux? Like what's going on there?
It's outside light is what we really need, and I think it's because the visual system is so good at adapting to different light levels. We're not really aware of the fact that we live in dim, dark caves. Most sitting rooms, offices, you'll be lucky to get 300-400 lux of light intensity, whereas right by a window, you'll get on average 3,000 lux. Shady environment will be maybe 10,000 lux, 20,000 lux. Bright sunny day, 80 to 100,000.
Oh, that's a huge difference between even just being indoors versus outdoors.
Yeah, absolutely. And so that's why morning light, outdoor light is so good. And it may be the explanation, for example, why individuals with dogs are reported to sleep better because, of course, they have to get up, take them for a walk in the morning, and they're getting their morning photon shower. And that's helping consolidate the sleep-wake rhythms of not only themselves, of course, but the dog.
And are we talking like 5 a.m. morning or like 10 a.m.? Like
no,
what sort of morning are we talking?
We're talking, I suppose, 7, 8 o'clock in the morning. I mean, certainly the earlier you get up, if you got up at 5 a.m., you would have a big advancing effect upon the clock. But most of the time, we're talking about a mild modulation of the clock, just nudging it to keep on track. Because on average, and again, I don't like to use averages, but the Harvard group have suggested that the human body clock is around about 24 hours and 12 minutes and 10 minutes. So we only need a slight adjustment every day. So it's not a huge adjustment. Unlike, of course, when we cross multiple time zones, and then we've got one heck of a shift because, we're 8 hours or 6 hours, or going to Australia, or New Zealand, 12 hours of time difference. And of course, it takes about a day for every time zone we've crossed to adjust, fully adjust. So and again, it goes back to that wonderful molecule SIC1, which is buffering the effects of light on the clock. Because, of course, it makes sense. It doesn't want, evolutionarily, huge shifting of the clock. It doesn't want it to be disturbed because, for example, you might then, if you're a burrowing mammal, emerge from your burrow too late or too early and be somebody else's lunch.
Yeah. So it sounds like, broadly, even though we don't like to give prescriptions to people, but going for a walk in the morning feels like a very reasonable, good thing to do.
And having your breakfast right by a window. The nursing home environment, where many individuals don't get out very much and where sleep-wake is really awful in some cases. And indeed, the light environment, Els van Sommeren, a wonderful colleague from the Netherlands, put in the nursing home environment big banks of lights of producing 1,000 to 2,000 lux, darkness in the bedrooms, and consolidated really ragged sleep-wake profiles into much more robust sleep-wake profiles. And what was interesting is that those individuals who showed a stable sleep-wake profile, their cognition went up by almost 10%.
Ooh,
so
nice.
There's a very nice correlation there with improved sleep and cognition in the elderly simply by regulating the circadian system.
One thing I noticed starkly, like 2 days ago, I happened to be in a co-working space on Baker Street, and it was quite dark and dim inside. And I was there for a few hours working on my book, and after I was doing this, I was thinking, why do I feel kind of sad? This is a bit weird. And then I went out, and then I sat in a cafe on Baker Street, and I was immediately just like, oh my God, life is great. I feel so good. And I was thinking, have I had enough coffee? Have I had enough sleep? And then I was like, wait a minute. It must be like natural light.
Yes.
Where this was quite a dingy co-working space. It was quite dark, very sort of yellow light and stuff. It just felt a bit like there was
that's a really important observation. So those photosensitive retinal ganglion cells we talked about, we originally thought of them as circadian light regulators. Then we discovered they're actually part of the pupil constriction is dependent upon those extraordinary new cells. And now we know that levels of alertness and mood can be regulated. So there's an acute effect of light detected by those cells on our behavior. And in fact, there's some really fascinating data showing, wonderful study compared light treatment, which was 30 minutes of 10,000 lux from a light box first thing in the morning, versus Prozac versus placebo. And by 8 weeks, Prozac was statistically different from placebo. By 2 weeks, light was statistically different from placebo. And by 8 weeks, light was much more effective than Prozac. Interestingly, they combined Prozac and light, and the two were additive, suggesting that they may be operating on our levels of alertness and mood via different regulatory systems. So we don't know what light is actually doing, whether it's a direct acute effect, increasing alertness and engagement in the brain, or something else. They're turning out. I think that's what's so really remarkable, because it's not just the regulation of the clock, these new receptors. They're having a whole role, in a sense, an unconscious effect of light on our biology, which, as you point out, is important on our mood, for example.
Yeah. So there's a lot of people that get kind of seasonal affective disorder.
Yes.
Is that basically a light intensity thing from what we know?
It seems to be. I mean, I think many of us were very skeptical when this was, seasonal affective disorder was first talked about, because what's the control? You can't sit somebody in front of a light box, without the lights on, because they kind of get it. And then the studies became much more effective and compared morning light versus evening light. And we've talked about the importance of morning light. Morning light was much more effective at regulating SAD than evening light, and very specifically blue light, which is where those photosensitive retinal ganglion cells are maximally sensitive, was more effective than other wavelengths, other colors, in reducing the effects of SAD. And so I think it's a real phenomenon. Friends who are psychiatrists don't think it is. They think it's just another form of of anxiety or depression. But I think the data are now sufficiently strong to show that there's a genuine light effect. Precisely what the mechanism is, we don't know. What we do know is it's not melatonin. And so we were talking about myths earlier. Yeah. So melatonin is often called a sleep hormone. It is emphatically not a sleep hormone.
Okay, what is it?
It's a biological marker of the dark.
Okay.
Which means, so if we again, if we can go back to my roots,
please, yeah.
and the comparative, what we know about melatonin in mammals is that the expanding seasons, so the increasing dark length in the autumn and winter, leads to an increasing release of melatonin. So melatonin maps the seasonal changes in light and dark. And what a sheep or a deer or something will do is use that increasing melatonin profile in the autumn to trigger reproduction, so that there's the breeding and there's the young are gestating over the winter, and they're born in the March when there's lots of fresh vegetation to sustain milk production and weaning. So that's the really exquisitely understood role of melatonin. Melatonin, if you look at individuals who are on beta blockers and you reduce their levels of melatonin by over 80%, then sleep is not really affected. If you look at quadriplegics...
Why beta blockers?
Because it blocks the sympathetic regulation of the pineal gland, which then regulates the output of melatonin. Okay. So it's quite interesting that people on beta blockers do show almost no melatonin release. But the interesting studies... And again, you have to read the papers. So there's a study showing quadriplegic individuals, those people who've tragically, severed their spinal cord, at the level of the neck, have nothing, below the neck, have terrible sleep. And that's the argument was originally, well, that's because they're not producing any pineal melatonin. Then you compare those individuals to paraplegics, who, of course, can regulate their pineal melatonin production, they also have terrible sleep, and it's not different from the quadriplegics. So it's the ghastliness of losing of not being mobile, that's the problem with the sleep, not the lack of melatonin. And in the best studies ever undertaken, taking melatonin before you go to bed can reduce the time it takes to get to sleep by 30 minutes. Now, I stress that's the best study ever undertaken. Many studies showed no effects whatsoever. So,
sorry, by best study, do you mean the most positive study,
exactly,
as opposed to the most best conducted study?
Exactly.
Okay,
yeah, the one that showed the greatest efficacy would be that. Yeah. So it can be thought of as a mild modulator. You also see people write, light in the middle of the night increases alertness because it's suppressing melatonin. Well, it does suppress melatonin, but the alerting effect occurs before there's any decrease in melatonin. So it's an acute effect upon the brain, not via melatonin. So there's a whole mass of again nonsense out there about melatonin.
Just on the melatonin note, because I know a bunch of people who are super into the whole optimizing human body type stuff, who will sort of think are dabbling with like microdosing melatonin or like taking melatonin when you're jet lagged. What does the research say on?
For melatonin, for jet lag, in some individuals, it can speed up a little bit the rate at which you lock on to the new time zone. So Josephine Arendts showed those findings a few years ago, but it's a mild effect.
So most of us shouldn't worry about taking melatonin.
I think not, and in fact, pilots are warned not to. Because it might have a slight sleep inductive effect. And even worse, if it does affect the clock, you don't know where the clock is with multiple, changes of time zones. I tried it a lot when I was flying to Australia, and I found that, in fact, it actually didn't help me at all. And in fact, it was quite weird because you're not recommended to take melatonin if you are vulnerable to depression or mental illness, because it's quite similar to things like serotonin. Now, I'm not, luckily, vulnerable to depression, but weirdly, after taking melatonin, and this is an N of 1, so, it counts for nothing, but I found I was not as robustly jolly as I normally am.
Nice.
So I stopped using it. And of course, the thing to do in the new time zone, if you're traveling west, seek out light.
Yep.
So, London to New York, get out in the afternoon in New York, and that will help you adjust. When traveling east for more than 3-4 time zones, then avoid morning light and seek out afternoon light. And that's because if you're still based on London time, you see light in the new time zone when you're traveling east that would delay the clock, shove you back towards Europe, rather than advance the clock and drag you forward to India or Australia.
We said morning light advances the clock?
Yes.
And evening light delays the clock?
That's right.
But afternoon light also delays the clock?
Afternoon light, of course, when you're in Australia, would be dusk in the UK, which would delay the clock, which is
Oh, okay. So it's not the nature of the light; it's the timing
of the light. Yeah.
Okay.
So what you need to do is you need to get when you're in Australia, you need to get light to advance the clock, and so because you're dragging it forward in time.
And when you say advance the clock, that means you're going to sleep later.
It would no. Advance the clock means you go to bed earlier and get up earlier, which is what's happening in Australia.
Okay.
Whereas, of course, if you get it at the wrong time, you could delay the clock and take you back to Europe. I know it's complicated, and you have to think about it.
Yeah.
But the key thing is work out when dawn and dusk is in London, let's say, and knowing that dusk delays the clock and
dusk delays D&D
and morning advances, work out what it would be in Australia and then exposure light.
So MADD, morning advances, dusk delays, and by advancing the body clock, that would drag you
forward to Australia in time. It would make you get up earlier, because remember they're getting up earlier. They're getting up 12 hours earlier than we are.
Yeah.
And of course, if you're going west to the States, they're getting up behind us.
Got it.
So you want to delay going west and advance going east. It's difficult to hold in one's mind.
Yeah, but
yes, but it'll click.
Yeah.
Oh God, yeah, that makes sense.
Yeah.
So how do you avoid morning light when you first arrive in Australia? Dark glasses.
Yeah. Oh,
sunglasses.
Sunglasses. Okay.
Yeah.
How much does that tend to reduce your lux?
That will reduce it very significantly.
Okay.
Yeah. I mean, it's not perfect, but I mean, you're in Australia, so you're not going to hang out in the hotel room, are you?
Yeah, no, true.
That would be foolish.
Okay. I heard something around you should watch the sunset in the evening because that will like do something to your circadian rhythm. What's going on there?
Well, again, it's all part of that dawn dusk exposure. Okay. And it's getting that symmetrical light exposure, which is nudging the clock backwards and forwards and keeping it on cue. And of course, when we're all agricultural workers, that's what we got. We're out at dawn and bed at dusk, and that's why we were so beautifully aligned. And that's what we've spent most of our evolutionary history. But industrialization essentially has cut us off from natural light exposure.
Yeah, because I guess like in the winter, there's not that many hours of daylight.
That's
and
one
so
problem.
If we were to get morning light and evening light in the winter time, would we end up sleeping for longer?
Well, so what we know is that the extreme situation in Scandinavia, if you go to Tromsø, where you don't get light for 2 months of the year, and there's constant light, of course, is that many families in Tromsø, they actually have a light room. So the whole family bundles into this room with light boxes to get their morning light exposure to set the clock. It's also fascinating what Arctic reindeer do.
Okay.
So during the 2 months of darkness, they turn off their circadian clocks. So they're not showing any 24-hour patterns at all. First of all, there's no light-dark cycle. So there's, kind of no point. But also, during the winter, the drive is to feed as much as you possibly can whenever the weather conditions permit. And of course, in summer, where there's constant light, again, there's no circadian change. But the key thing during summer is you feed all the time because you've got to pack on enough calories
to last the winter.
The winter. So that's a great example of where a clock actually isn't of any adaptive value. So in those animals, those Arctic animals, you turn it off. Now, in humans, we've only been in those environments for a few thousand years, except for the native peoples in northern, in the Arctic Circle. We don't quite know what's going on with those individuals. But certainly in those Arctic animals, you have an adaptive response where they turn their clocks off.
So in terms of sort of actionable things, broadly, sleeping and waking up at the same time each day with a bit of leeway because it's a wobbly baseline rather than a regimented thing. Going for a walk in the morning is the first thing, very reasonable thing to do. Getting some level of like natural light exposure in the evening as well. Yeah,
I mean, I think that's right. As long as it's symmetrical, that's great.
And by symmetrical, you mean?
I mean, so that you're getting dawn and dusk. You're not just getting dusk, which is what which would just delay the clock, like those university students. Yeah.
Okay, that makes a lot of sense. What's the deal with you should dim the lights and stuff in the evening, and you should put on candles in the evening, and you won't do light blockers in the evening? What's going on there?
So this is another issue I have, and so if you read the press, then looking at a Kindle before you go to bed is an absolute disaster because it'll change your sleep-wake timing. There are data that looked at this. So the Harvard group got people to look at a Kindle on its brightest intensity for 4 hours just before bedtime on 5 consecutive nights. And it just statistically delayed sleep onset by 10 minutes.
Oh, perfect. Because I read Kindle before bed.
As
on a dim orange light setting. But,
one of my colleagues said, well, it may be statistically significant, but it's biologically meaningless.
Right.
So going back to our point earlier, which is you need a lot of light for a long duration to actually affect the clock. And so these devices, the Kindles are producing 30 lux.
Oh, okay.
Now, you can get an effect on the clock with 200 lux or so, but you need 6.5 hours of exposure.
Right.
So again, it's titrating intensity and duration.
Yeah.
So there will be a slight wobble, but it's going to be very mild. And of course, if you're getting morning natural light, it's going to correct any evening wobble. So from most devices, the light is not the issue. It's the alerting effect. And where we have really nice data are for smartphones, for example, which have this incredible alerting effect, not least in teenagers. And that will increase levels of alertness and therefore delay sleep onset. Lovely anecdote. I mean, I remember speaking to a young lad, and I said, not smart, to look at your smartphone before you go to bed. He said, look, it's okay with my computer, my smartphone. I've got a device which changes the color from blue to red, so it's just not a problem for me, okay? And I said, okay, well, there's not really much evidence that has much of an effect at all. And by the way, what time are you getting to sleep? He said, well, about 2:30 in the morning. And so you can actually fool yourself that you're protecting yourself with a screen that changes its color.
Yeah.
And actually it's not having an effect at all, other than, it's on the clock. It's essentially this alerting effect that it does. And many young people are aware that this is not a smart idea, but the anxiety of being disconnected from social media and the friend circle is overwhelming. And so it's our advice is always, look, try and be disciplined about it. Yeah. And I know how difficult it is. We talked about Australia. Those of you who remember BlackBerries, I just got my BlackBerry, and you may remember we used to have one of those red lights that used to sort of glow when there was a message. So I had my Australian emails. That was fine. And then the European ones would come in, which of course would be bedtime. And then the American ones would come in, which of course would be even later. And so I know I'm weak like everybody else. Yeah. I had to leave my BlackBerry in the lab because I would, because I had jet lag, I wasn't sleeping great, and I'd sort of wake up and I'd see this glowing red light. And so I think if it is a problem, you had to do something about it, which is detach yourself from it.
I found like one of the biggest sort of tweaks I made to my sleep was just moving my phone charger across the room rather than on my bedside table. Yes. So now the only thing I have on my bedside is a Kindle and a fan.
Well, I think there's a strong argument for all of us not to use our phones as alarm clocks and go back to an old, either digital or, mechanical. You have to be slightly careful because some people clock watch, which means you wake up, as we've discussed, and of course, normally, most of us would fall back to sleep. It's not a big deal. But then you see the glowing dial on your bedside table and think, oh my God, I've only got 2 hours before the alarm goes off. And it then sends you into a state of anxiety, which means you won't get back to sleep. So for those individuals, just cover up the digital numbers. Because it's actually the important thing is when the alarm goes off, not how long it is before the alarm goes off.
Yeah, I remember. So this morning, I have my alarm set for 7:30, but I woke up at like 6:50, and I was thinking, I feel pretty alert right now, but I know I'm going to talk to you, and so I was like, I wonder if I should just. And I went back to sleep and woke up at 7:30.
Yeah, well, that's right. That's it.
I was thinking about it for like 30 seconds, and then
it's a great example whereby one just can chill, and you can go back, and you can get that. It's the terror of waking up. Again, it's part of that sort of. We're so frightened of the sleep we're not getting that we then don't get it. It's such a shame.
So is it better for you to wake up without needing an alarm, or are alarms totally reasonable?
If you're waking up naturally without an alarm, it's telling you probably had a good night's sleep. You also may wake up remembering your dream because, of course, we go through a series of stages, which is sort of the non-REM REM cycle, REM standing for rapid eye movement sleep, which is when you're sort of essentially paralyzed from the neck down, and your eyes. If you've got a sleeping partner, it's sometimes fascinating to see the eyes wobbling behind the eyelids. If you don't have a sleeping partner, then you can sit in your dog or whatever, and it's just such an incredible state. But it's during REM sleep that we have our most vivid dreams, and we wake naturally from REM sleep. So those individuals who are waking up in the morning naturally are much more likely to remember their dreams. And while we're talking about dreams, I think it's really important to stress There's nothing to worry about with dreams.
Yep.
Dreams are a way of the brain probably trying to make sense of our emotions and struggling with what we may or may not have experienced, during the previous few days. They do not anticipate things. There's no evidence for that whatsoever, but they do seem to be associated with our emotional status. So, for example, after the Twin Towers were destroyed, there were lots of dreams, not of seeing planes crash into the buildings, which is interesting because that was the image that was constantly on the television. But people had anxiety dreams of being mugged, being overwhelmed by a tsunami. So yes, our dreams do reflect our emotional status, but you shouldn't be worried about them because it's the brain trying to work through these issues.
Just on the point of the whole blue light, yellow light thing.
Yeah.
Every device these days seems to have a nighttime setting where it'll suddenly go orange, and
yes,
I guess that lulls us into a false sense of security. Oh, it's not too bad using my computer at like midnight because it's orange.
I think that's the thing.
Yeah.
Yes. There's very little evidence that shift in wavelength color will have any effect upon the clock. Color is only important when under certain circumstances. If the light is bright, it doesn't really matter what the color is.
Okay.
And we can talk about blue glasses in a moment. I think it does lull us into a false sense of security, and you just need to stop using these devices. It could well have a mild effect because, after all, these cells are maximally sensitive to the blue part of the spectrum, but you're so low that it probably just doesn't matter much.
So it's more about the alerting.
Exactly. It's the alerting effect of the content that you're processing, and it may well be some contribution of the alerting effect of light. It looks as though the threshold for regulation of the clock is higher. You need more light to regulate the clock than you would to have an alerting effect. Ironically, what's the last thing that most of us do, which is stand in the most brightly lit room in the house, the bathroom, looking into an illuminated mirror while we clean our teeth. And I've often thought there's a commercial opportunity to have a bathroom mirror with a bright morning light setting to increase alertness as before we leave the house, and slightly dim it to reduce alertness before we go to bed.
Yeah. So in the place I'm in at the moment, there's a dimmer switch in the bathroom. And it's so good. Like as soon as it's nighttime, I'm just like dim all the way down, and then I feel like. Yeah. So presumably a light like this on full blast would probably not be advisable, but even then, I guess.
Yeah. I think that's it. It's not going to have too much of an effect on the clock, but it will have levels of alertness. And we go back to one of the questions you asked earlier, which is how much light, what's the color, how long, and for humans we just don't really have those data to design proper human-centric lighting for our indoor spaces. It's a huge area of interest at the moment. It's tricky. We need more research. And, and it's not as though we couldn't do it. We can measure the spectral composition from small devices. We can measure the intensity. And what I'd love to do is get a whole bunch of people and measure their light exposure, wavelength, intensity throughout the day, their levels of alertness with a simple sort of response on a smartphone, their sleep-wake timing. You could collect all this data, cross-correlate, and then actually get some good baseline data for human-centric lighting. Worth bearing in mind, of course, that the most important light is at dawn and dusk. So what we do in the middle of the day may not matter that much. That's the prediction, but we don't have the data.
So we were talking a little bit about like the blue light stuff. Presumably then blue light glasses are a bit of a myth?
Yes, and in fact, if you think about what blue light glasses do, they will transmit blue and block out all the other wavelengths. But
transmit blue but block out.
So a filter works because it transmits one particular wavelength.
Okay.
It passes through the glass and blocks others.
Right.
So it's not increasing the amount of blue light. It's exactly the same. It's just, filtering blue light. So if people use blue glasses to enhance their alertness, then
exactly.
There's no more blue light. It's just blue light.
And similar to blue light blocking glasses.
And blue light blocking glasses.
Because they're just getting rid of the blue.
They're just getting rid of the blue. Okay. And do blue blocking lenses work? Well, they probably have some effect upon alertness. They may have some effect upon shifting the clock, but it's going to be very mild. If the light is bright enough, it doesn't matter what the color is. Yeah. So if you're outside, you're going to be exposed to so much light, in the hundreds to thousands of lux range, that will shift the clock. And in fact, there was a consensus statement just produced recently from, I think, Australasian ophthalmologists, which suggested that blue blocking and blue enhancing glasses had no effect at all, and they were not recommended. I mean, we did some work on cataract surgery. So, if you have a cataract, and incidentally, there's an interesting observation here, which you might find amusing. Why is it that perfectly respectable elderly ladies have a blue rinse? You know, they have their hair dyed blue.
Oh, do they?
They're in the olden days.
Oh, okay, right.
And it's still to some extent. And that's because they don't want their hair to look yellow. So what happens as you age is your lens yellows. So white hair looks yellow.
White teeth will look yellow, yeah.
Yes, and so therefore blue will make their hair look white. So that's an old historical reference.
Nice.
But anyway, so we asked the question, do blue blocking versus UV blocking lenses make any difference to sleep-wake regulation after cataract surgery? And now we've done calculations showing that most commercially available blue blocking lenses actually transmit more blue light than a normal healthy lens. So it's not going to scrub the circadian system. Yeah. And that's exactly what we found. We found no difference between UV blocking and blue blocking on sleep-wake timing after cataract surgery. People still use blue blocking in the clinic because there's some not great data suggesting that blue light might enhance age-related macular degeneration. Now, the evidence for that in a dish, in vitro, is reasonably good, but in vivo, in humans, the data are not good at all. But I think that people err on the side of caution and will use a blue blocking lens under most circumstances.
So when I was getting these glasses from the eye people, they were like, well, you can pay an extra £100 and you can get blue light thing on them. I was like, why? And they were like, well, if you work with a screen a lot, it might be good for you. I was like, okay. I mean, I work with the screen a lot. And now I have this sort of slightly yellow hue in my glasses, which I now kind of want to get rid of because it's actually just makes the world slightly unpleasant.
Yeah. Why would you do it?
Well, but the optician chap upsold me on this £100 upgrade because apparently it's better for you if you use a screen. Do you know what he's getting at there, or is it complete myth?
Yeah, it's part of this whole myth again. I mean, this is that, blue blocking, slightly yellow tinted is good if you're looking at the screen a lot. Yeah. But why? I mean, you're going to get much more blue light by walking outside. And I don't think we have any real evidence base for a lot of the stuff that's being peddled at the moment. Now, I'm very happy to change my mind and admit that, with new data, it may be important, but we don't at the moment have the data.
Nice.
And it would be very valuable, I think, for you when you go back to your optician to say, point me to the paper where this has been shown to be effective. And I think everybody should be doing that. I think we should be challenging, all of this by saying, I'm very happy to do it, but just show me the paper and where it's statistically significant. Maybe I'm just becoming a bit grumpy as I get older.
All right, time to get rid of these blue. One thing I've heard is that it is, quote, good for you if in the evening you light candles, because like the low, sort of getting light from a low area, like a candle or a lamp, the photosensitive retinal ganglion cells respond differently to light from above. So turn off the ceiling lights and turn on the lamp lights.
Again, I don't know what the evidence base for that is. But of course, light, in addition to its alerting effect, and of course its regulation of the clock, will impinge upon our emotions, but depending upon context. Romantic candles. And it could well be an association that we make with these different light sources rather than any direct physiological response. I wouldn't say, I suppose you could call it perhaps a placebo effect. It's a perceived impact, but actually it may just be, in the cortex rather than any
rather than the suprachiasmatic nucleus.
Structures.
Yeah. So like, I'm lighting my candles. It's my wind down routine. It's nice. I'm going to sleep soon.
And actually, we're joking, but actually developing a wind down routine at the end of the day is really important before you go to bed. And if it's candles that do it, and even sort of some form of smell, whether it be lavender or something else, the evidence that sort of oils actually do have an effect above placebo is not very good. In fact, it's negligible. But if it works, then I think that's fine. It's like any relaxation techniques. I mean, I have to say, in the early days when people were sort of peddling mindfulness, I sort of put it in the box of crystal waving, right. And that's of my grumpy sort of background as really I want mechanisms, I want physiology, I want to understand how it actually works. And then actually I sort of studied it a bit, and I realized essentially what mindfulness is a brilliant way of finding relaxation techniques, and relaxation techniques work. We don't understand necessarily the mechanisms, but they do work. And so at the end of the day, trying to get rid of the stresses, then I think relaxation techniques, whatever they are, can be extremely useful. I mean, in our house, I ban the discussion of family finances, and it's a shame because it's often the only time of the day that couples do have chance to talk about sort of serious issues, because you get up, you rush off to work, you then get your dinner, and then you have that sort of period of relaxation. But actually what you don't want to fill that time with is angst promoting discussions. And so I think trying to find a time, maybe at the weekend, where you can have those discussions is so important, but not immediately before you go to bed. My wife still tries though.
Oh yeah. Family finances. So you talk in the book a little bit about stress and the effects of stress on, how does stress and body circadian rhythms and sleep and stuff interact?
I think this is such an important point. Most people don't have a sleep problem; they have a sleep or anxiety problem, and so the worry that they have is preventing them getting the sleep that they need. And I think while we're talking about it, it's worth distinguishing between sleepiness and fatigue. Sleepiness is cured by the opportunity to sleep. Fatigue is you can be sleeping a lot longer, but you're still feeling tired, exhausted, lacking energy during the day. Yeah. And so many people with COVID, for example, had fatigue. They had long periods of sleep, but they were still feeling exhausted and below par. And what fatigue represents is an underlying health issue, which is different from sleepiness. So if you get persistent fatigue, then there's a chance you have some underlying health issue which you need to get explored. I was chatting to somebody in the States just recently, and she was telling me that she was feeling tired all the day. She couldn't work, and then she'd go to bed, and then she'd wake up in the night. And of course, ideally, you'd fall back to sleep. But she was so alarmed at all the stuff she'd failed to do during the day, she couldn't then get back to sleep. And it transpired, actually, she had an immune problem, which, of course, was leading to her fatigue. And so sorting out the immune issue, which was causing the fatigue, which then was causing the anxiety, which was then stopping her sleep. And so I think it's really important to try and dissect all of these things. What does stress do? It increases blood pressure. It increases levels of alertness. It pumps out the cortisol and adrenaline. It makes us more alert. And so if you are stressed, it's going to be tricky to sleep. And so that's why it's so important to make that detachment at the end of the day from the things that have upset you. Mindfulness, anything, yoga, whatever. And of course, the problem during COVID and since is that many people's bedrooms have become their places of work because the bedroom has where you can set up your office. Yeah. And that's of course, there may, for many people, be no other possibility. But by combining your sleeping space with your workspace, it means that your opportunity to sleep is going to be affected by, maybe I should just check the email again, before I go to sleep, or whatever. Or if you wake up, the tendency is, just check if those emails came in from the States. And it has such an alerting effect, you won't go back to sleep. So if you do have to have your office in your bedroom, you've got to be really disciplined, turn everything off, and make it a real pain to have to turn it on if you happen to wake in the night.
Yeah. So I guess, do you know what the data is around? I mean, I've heard that acute stress is kind of good for you, but chronic stress is bad for you.
Yeah, I think that's a really important point. And I have likened stress to a bit like the gears of an engine. So acute stress is like first gear. It gives you that wonderful acceleration. You can get away and do your stuff. But if you leave the engine in first gear, chronic stress, then you're going to destroy the engine. And that's, I think, a very interesting analogy because, yes, stress, and we give, stress a bad time, but actually it's evolutionarily really important. It gives us that massive acceleration to get out of problems, the fight or flight response. But it's where we have to keep on turning that mechanism on to function. And that's what tired people do. A night shift worker, their entire biology is in the sleep mode. It's really important to stress that night shift workers, 97% of night shift workers, do not adapt to the demands of working at night. So they're working against an entire biology, which is saying you should be asleep. And the override for that, of course, is turning on the stress axis, which, of course, which explains why long-term night shift work is associated with such chronic health conditions, coronary heart disease, type 2 diabetes. What are you doing when you turn the stress axis on? You're throwing glucose into the circulation to try and burn it up because you're going to need it for running away or fighting. Now, if you're not, then you become glucose intolerant. So obesity, same thing. Higher rates of cancer in night shift workers, because what happens, one thing we know about high levels of cortisol, they'll suppress the immune system, making you more vulnerable to not only infection, but cancer. Well, so stress and sleep, and the need to activate the stress axis to override the need to sleep is such an important part of our 24/7 society.
This might be a little bit outside of your field of expertise, but I wonder if you have a thought on this. Around stress and kind of taking vacations where you switch off from work, I guess. And I guess I'm asking because in this, when I was working as a doctor, it was easy enough to switch off from work because being a complete junior, I have no responsibility for anything that happens when I'm not around. So broadly, it was good, unless I was like, oh crap, have I made a mistake? I've heard that consultants were a bit more on edge about this because they're responsible for patients overnight. But now doing this YouTube podcast, writing type stuff, in a way, my work is my life, and it's so tightly integrated that when I take time off, I'm still always doing some work-related thing or another. And people will say, oh, it's really important to fully switch off. And I'd be like, well, I don't know. I kind of enjoy it, but I don't know if I'm bullshitting myself. Yeah,
I'm kind of like you. I don't feel as though I completely switch off. I'm going to be taking a holiday later this week. But what are my plans? What do I want to do? Well, I want to kind of do a bit of reading around my subject area. And I find that relaxing. I wouldn't do that immediately before going to bed. I've got this wonderful new book I want to sort of read, but it'll be during the day. So I think, again, you do the stuff that relaxes you. Yeah. And of course, it's going to be some people lying on the beach, other people doing different things, other people mixing up a naughty cocktail. Yeah. And I think it's very much up to the individual.
So we've talked a little bit about stress. How does I guess exercise relate to our circadian rhythm?
Yeah, that's interesting. First thing is that part of the sleep mechanism is a drop in core body temperature. And individuals, if you block that drop in core body temperature, it's more difficult to get to sleep. And it's only about a drop of about a degree. So if you exercise late fairly shortly before you go to bed, you're going to increase core body temperature, and it might be more difficult to get off to sleep. Exercise depends why you want to exercise. If you want to burn calories, then there's two ideas. That because nighttime, we're in a different metabolic status. So during nighttime, we are burning stored calories. And we're mobilizing those calories to keep metabolism going throughout the sleeping state. During the day, we're taking calories in and we're metabolizing those calories and burning them up, ideally. So if you want to exercise before breakfast, first thing in the morning, you're still in the sleep metabolic status. So you're burning up stored calories, which for some people is what they want to do. The trouble is, our ability to exercise increases throughout the day. So most track records, swimming records, other athletic performance is peaking in the late afternoon and early evening. So you'll notice, people at the Olympics know this. So the finals are always late afternoon, early evening, because that's when individuals can exercise for longer with greater power.
Yeah.
So if you want to, if you're more of an evening person, as I am, then I am likely to I will be able to exercise for longer and exert greater power later in the day than first thing in the morning. Now, if you're a morning person, getting up and doing your exercise before breakfast, that's great. For those of us who would find that particularly difficult, then I think late afternoon and early evening is where you go.
Yeah, I tried so hard to be a kind of wake up early in the morning, go to the gym before going to work kind of guy. But I would always find that it would just be such a chore and I wouldn't look forward to it. And I'd be like, oh, why am I doing this? This is the worst thing ever. And now when I go to the gym at like 5, 6 p.m., I'm having a great time.
That's it. I think that's it. You find out really what works best for you. And it's interesting because it relates to eating. Our eating habits have changed profoundly with the Industrial Revolution. During the 1100s or so, the main meal of the day was breakfast. During the Middle Ages, 1100 to 1500, it shifted to noon, and I mean 12 o'clock, 12 o'clock. And that's where the main meal of the day, and we think of all those Tudor banquets, with people throwing chicken legs all over the place. That was actually at lunchtime, not in the evening. Yeah. But with the industrialization and that the workspace was different from the living space and commutes and all the rest of it, our main meal of the day, many of us will run out the door with breakfast, maybe a tiny breakfast. We probably don't have time for lunch, so we may have a sandwich in front of the computer, and then we'll get home after a long commute, shove something in the microwave, and then we'll be massively having a massive calorie load, late in the day. And what's been shown is that there's a circadian regulation of our metabolism. So there was a wonderful study looking at the same meal at 8 a.m. versus 8 p.m. And those individuals who, same people, but when they had the meal at 8 p.m., circulating levels of glucose were 17% higher than the same meal at 8 a.m. Okay. And of course, eating late into the day, high levels of glucose, greater risk of diabetes 2, obesity, and all the rest of it. So when you eat is really important. And the data now are very, very persuasive. Oh,
wow. So my late night Five Guys is like worse than my mid-afternoon Five Guys.
Absolutely.
Oh, wow. Okay,
yes,
cool.
Yes.
That's useful to know.
And of course, when you're young, you're burning it off, and you're much better. It's when you get to my decrepit age that you really shouldn't. And so we as a family have shifted our meal times, and we try not to eat late because of the greater risks.
Does that sort of eating, because some people say that, don't eat anything 4 hours before bed or something like that. Does that help you go to sleep if you're not eating at that time? Or
no, I mean, it's tricky because some people feel that they need to go to bed on a full stomach to sleep better. And the science behind that, I don't know. I don't know quite what's going on there. But certainly some people talk about it. Ideally, all the data would now suggest that try and minimize your calorie intake, I think, before 4 hours or so before you go to bed, because of the metabolic side effects.
Okay, rather than because of the sleep side effects.
Yeah.
Broadly. Okay, awesome. We talked a little bit about body temperature. One of the things that everyone started doing after Matthew Walker's book came out was sleeping at 19 degrees and turning the AC on to max and getting these fancy mattresses that cool your bed. Do you know what the data is on those things? Anecdotally, I found it helpful to sleep in a very cold room, but yeah.
And as do I, anecdotally, and certainly. That drop in core body temperature prior to sleep is important. Whether we need to sleep in, a cold air-conditioned room, I'm not sure. There is evidence, not huge, but there is some evidence that those mattresses that take away heat from the body do improve sleep and get you off to sleep. So I think there's something emerging there. And indeed, I am working with a mattress company. I'm advising them because I do think there's something there. And they approached me. And what was interesting about them is that they wanted to do the studies, which will show this or not. They wanted an evidence base for saying that, yes, here's the evidence and it does make a difference. And so that's why I was interested in working with them and advising them.
We talked a little bit earlier about kind of morning person, evening person, and the idea of chronotype.
Yes.
How does one figure out their chronotype?
It's not that difficult. There are questionnaires that you can fill in.
Appendix,
there's a questionnaire in Lifetime, which is a well-validated questionnaire, and it basically asks you, your preferences to a whole bunch of things. And I think it raises. I think it's interesting if you know your chronotype because it might help you explain certain aspects of your behavior. But certainly, I've also wanted to encourage employers to take chronotype into account. So if you're on the night shift, it would make an awful lot of sense if you had a later chronotype versus a morning chronotype. And not that you would remove all of the problems of night shift work, but if you could match your workforce, so for example, I've urged banks to say, right, this is 24/7 business. Why don't you develop teams whereby they're the morning types, the middle types, and they're called larks, doves, and owls.
Right.
But there are a whole bunch of other animals that are being used as well for these classifications. I like the old, larks, doves, and owls. And then you've got a team that can span the 24/7 banking sector that will make it easier. I mean, you put the owls on the American when the American banks are at their peak, and the larks will be when the Asian banks are at their peak. And I think that working together across chronotypes could be really valuable.
Yeah. Because there's a lot of moralizing about the whole wake up at 5 a.m. and you are better than the sort of person that wakes up at 11 a.m. kind of thing.
Oh, God. Yeah. It's just that whole machismo of, and of course, those of us that remember the 80s, people would bounce in and say, oh, I've done another all-nighter. And, people used to slap them on the back. And that's just nonsense. I mean, would you want in the workplace people who were lacking in empathy, overly impulsive, and incapable of making sensible decisions? No. I mean, that's the consequence of not getting enough sleep. And so, I think those days, hopefully, mercifully, are gone. Although I understand the banking community, there was a survey last year, and some, I think, young bankers were saying, we're going to resign. If you put, there's huge working hours, completely stressed. I think the majority were getting less than 5 hours sleep a night, which maybe a fraction wouldn't, could cope on that generally, but most would not. And of course, do you really want the people looking after our pensions and our national economies, overly impulsive and failing to make and making sensible decisions about the economy? No. So I would, in the same way that the medical profession has to some extent ignored the impact of night shift work, I think the financial sector is another sector that really needs to start to take it seriously.
I was going to ask about these little crib sheets you've got in front of you.
Oh, yeah.
Because it seems like you haven't really consulted them, but I wonder what's on them.
So if one was going to structure, what could you do to develop sort of an optimum sleeping regime?
Perfect.
Okay. So then I think you can divide sort of the day into 4 sections. I mean, so during the day, we've talked about light. for most of us, 90% of us, it would be getting morning light to set the clock. What about napping? So a 20-minute nap in the early afternoon has been shown to be effective. So the occasional nap, can make you function better during the second half of the day. And some companies, offer a 20-minute nap. Longer than 20-minute nap, you can drop into a deeper level of sleep, and then recovery from that, the sleep inertia that you experience, can make you groggy, and it can be counterproductive. But a short nap can be effective.
And are we talking 20 minutes of actual sleeping, or?
Yeah, I mean, you basically will set your timer for 20 minutes, and if you're tired, you need a nap, you'll probably fall asleep for most of that. There's a big problem, though, for teenagers. So they, for reasons we've discussed, tend to have shortened sleep. So they're going to sleep, they're waking up chronically tired, and when you talk to teachers, there are kids falling asleep at their desk. They then get home. They then will sleep for 2 or 3 hours, relatively close to bedtime. That pushes back sleep pressure, which means it's more difficult to get to sleep that night. So you fall into a cycle of later, delayed sleep, shortened sleep, and then extended, not naps, but really sleeps during the day. So you need to be careful you don't fall into that cycle. So napping can be useful occasionally, that's fine. Exercise, again, we've touched on, not too close to bedtime, because, of course, it can raise core body temperature. But the key thing is to exercise. Concentrating food intake during the first and middle parts of the day. Why? Well, of course, if you're having your calorie intake towards the end of the day, you're much more likely to lay it down as fat. You are more likely to have conditions like obstructive sleep apnea, which can massively harm your sleep at night. So, that's one thing to be careful of. Avoid excessive consumption of caffeine. So many of us will not drink coffee after 2 or 3 o'clock in the afternoon. Caffeine has a long half-life. I mean, depending on who you are, 5 to 9 hours. So, a late afternoon cup of coffee can, again, delay sleep at that night. When you leave work, when you stop work, you've got to make time to step back and switch into another mode, some sort of relaxation. You mentioned going to the gym. That's great. It's doing something that is completely different from your work. So that's sort of things you can think about during the day. Before bed, reduce the light. Again, we've touched on this. It's not because it's going to have a big effect upon the clock. Light will have an alerting effect. So minimize light exposure 30 minutes before you go to bed. Stop using electronic devices. Again, same thing. You need to be winding down. Ideally, avoid prescription sedatives. It's really important to be aware that sleeping tablets are sedatives. They do not provide a biological mimic for sleep. Basically they encourage a neurotransmitter which turns off all of those alerting neurotransmitters in the brain. And it's been shown that it can reduce, for example, memory consolidation and can promote daytime sleepiness, particularly in the elderly. And sleeping tablets are really not recommended for things like dementia and stuff like that. Alcohol. Many people will have a sort of a cycle of excessive coffee during the day to keep themselves awake, and then sedate themselves with alcohol at night. Really bad idea. Alcohol is again a sedative. It can disrupt the natural pattern of REM, non-REM sleep, and it can again harm memory consolidation and the processing of information. Again, we've touched on this. Before you go to bed, avoid discussing topics that have a stressful or alerting effect upon you. And then finally, before bed, it's wind down. And whether it's reading that Kindle, which works for you, whether it's listening to a piece of classical music, whether it's listening to Radio 4 Extra, whatever it is, what works for you. So that's sort of during the day and before bed. The bedroom itself, shouldn't be too warm. Again, we've talked about this loss in core body temperature. If the bedroom is too warm, it's much more difficult to get off to sleep. Again, ideally, it should be quiet. Now, that's tricky. Of course, in many sort of apartments and flats, people have used white noise or relaxing sounds such as whale song or the sea. And again, try it out. It may work. Dark, if possible, and particularly if you're getting a lot of street lighting through, you can get blackout curtains that can go behind your normal curtains. As much as you possibly can, remove TV, computers, all of those sorts of alerting effects from the bedroom space. As we've discussed, really tricky because many bedrooms have become also offices. So make it difficult to turn those devices on. Don't clock watch. Again, we've touched on this. The illuminated dial on your clock can be used if you wake up, think, oh my God, I've only got a few hours before I have to get up. It doesn't matter. So cover it up. And of course, don't use your smartphone. So maybe just go back to an old mechanical clock. Although I'm told that the TikTok now for some people drives them completely crazy. Sleep apps. Don't take sleep apps seriously. Again, as we've discussed, none of them are endorsed by the National Sleep Federations. They can be deeply misleading and can actually make you more anxious about your sleep. What they're useful for is telling you roughly when you went to sleep, how many times you woke in the night, and when you woke up. That can be useful because if you want to change your sleep timing or your sleep duration, then you can modify your behaviors and then have an accurate record of that with your app. So in the same way, if you want to lose weight, you can change your eating behavior. You weigh yourself in the morning, you see a change in weight, and that reinforces your changed eating behavior. But don't start getting obsessed about, oh, I had a good night's sleep, or I had lots of slow wave sleep. They're just not accurate enough at the moment to give you that information. Then, of course, in bed, again, try to keep to a routine, go to bed and get up at the same times. Ensure that the bed is comfortable and large enough. I do feel that we Brits are kind of cheap about our bedding. It's a third of our lives, and yet we're very reluctant to spend on, decent mattresses and pillows. And of course, it depends on who you are. Go try them out. Talk to friends, family about that sort of thing. But I do think it's important to take it seriously and invest in good bedding. Keep bedside lights low. Again, you can read comfortably, but you don't have to have them too bright, so it'll have an alerting effect. Now, some people sort of define the sleeping space with relaxing oils, such as lavender. And that can be useful. The evidence that it actually works is not great. But what also people might do is if they're traveling a lot, they may take their partner's aftershave or perfume and then define the sleeping space, for them in a foreign place, which can aid sleep. So that's fine. Earplugs. Now, this is a really interesting area. If your partner snores, then earplugs is one solution. Many people can't cope with earplugs. And so I recommend, if you can, finding an alternative sleeping space. Now, that idea for many, particularly sort of older couples, is the sort of the signature of death for the relationship. It absolutely isn't. Whether you sleep in the same bed or not, it does not define the quality of your relationship. And I would argue, in fact, if you're getting a better night's sleep in a room next door, you'll be more empathetic, you'll have more fun together, and you'll be a better person. So don't worry if you feel you need to sleep elsewhere. That, as I say, doesn't define your relationship. What you do need to be very careful about is that your partner, it doesn't have obstructive sleep apnea. And that's where there's a cessation, a stopping of breathing for a period of time. And then they'll wake up with a gasp and so on. Now, that's really serious. And basically what obstructive sleep apnea is a collapse of the musculature of the throat, which actually blocks the breathing channels, which means you're depriving the brain of oxygen. It detects it's not getting the oxygen it needs, and so it will then wake you up. Now, but that great surge in blood pressure without waking up has been associated with damage to the small vasculature within the eye and the brain. And of course, those individuals with obstructive sleep apnea have higher rates of coronary heart disease and all the rest of it. Exactly, cause and correlation is unclear, but you do need to get it looked at. It's a serious issue. It's been estimated that a very large number of those individuals driving our buses and trains have obstructive sleep apnea, causing, of course, daytime sleepiness and all of the other health areas. So get that looked at. And it can, CPAP, which is this sort of forced air mask, can take a little bit of time to get used to, but it works in over 90% of cases. So it's fixable. And finally, as we have discussed, if you wake, stay calm. It's not necessarily the end of sleep. You just need to maybe, if you're not falling back to sleep immediately, go to another space and relax, and then return to the bed when you feel able to sleep again. The key thing is there's lots of things that you can try. Sleep. So many people think sleep is what you get, and it's not. We can have a lot of control over our sleep if we're not anxious about it. And as soon as you've found something that works for you, stick to it. Defend your sleep.
Love it. Firstly, thank you so much. This has been wonderful. I guess final thing I'd like to sort of end with is, you've had a pretty illustrious career. You're a professor now. You teach all these students. We have a lot of students and young people listening or watching to this podcast. I guess, what would be your top tips for if you were able to have a platform to advise young people about anything or other for, I guess, succeeding in life, staying happy, healthy?
Yeah, I think it's really important that we get education about the importance of sleep and circadian rhythms embedded within our schools. And just making the point that if you don't get enough sleep, then you're going to have a negative view of the world. There's some really amazing studies showing that tired people remember the negative experiences, but forget the positive ones. So, it's difficult enough being young as it is, but only remembering the ghastly stuff that's going on rather than the good stuff means your worldview is completely changed. Knowing that not having enough sleep, you're going to be more irritable, you're going to be more anxious, that you'll have loss of empathy. You'll show greater levels of frustration. You'll show increased tendency to use stimulants and then sedatives. You'll have decreased cognitive performance. This is the time of one's life when you're packing in, your educational opportunities, and not embracing one's education because of lack of sleep is a terrible squandering of resources. You'd have poor memory and concentration without good sleep. You'll have impaired decision-making capacity and creativity. So all the sorts of things that make us this extraordinary species, humor, the ability to absorb and use information, all of this is inhibited by sleep. And you'll also show reduced social connectivity. So sleep is not an indulgence. It's not a luxury. It's something that is 30% of our biology or more and needs to be embraced. And it makes you a happier, healthier, lovelier person. And it means what you can do is, I suppose, embrace all of the opportunities that the world has to offer. And not getting enough sleep is kind of a terrible squandering of opportunity.
Fantastic. Professor Foster, thank you so much. This has been wonderful.
Great
where can people learn more about you if they would want to follow up more of your work?
Oh, well, there's Lifetime, of course, which I've just finished. So, much of what we've discussed is in Lifetime. And then you can track me down on our website, the Sleep and Circadian Neuroscience Institute at the University of Oxford.
Brilliant. Thank you so much.
Great pleasure. Thank you.
All right, so that's it for this week's episode of Deep Dive. Thank you so much for watching or listening. All the links and resources that we mentioned in the podcast are going to be linked down in the video description or in the show notes, depending on where you're watching or listening to this. If you're listening to this on a podcast platform, then do please leave us a review on the iTunes store. It really helps other people discover the podcast. Or if you're watching this in full HD or 4K on YouTube, then you can leave a comment down below and ask any questions or any insights or any thoughts about the episode. That would be awesome. And if you enjoyed this episode, you might like to check out this episode here as well, which links in with some of the stuff that we talked about in the episode. So thanks for watching. Do hit the subscribe button if you aren't already, and I'll see you next time. Bye-bye.